All right, today's notes are on logarithmic functions. You may have seen these in pre-calculus or college algebra. Before we get started with this, I want to just do a quick little Algebra 2 review. All right, so we've been working with problems where we've dealt a little bit with negative exponents in our last section with exponential functions. So remember, there's a way we can rewrite this. I can write it using the reciprocal 1/5 to the second power. Or I should say 1/5 to the second power. All right, so we'll need to keep these negative exponent rules in mind when we're dealing with our logarithmic functions today. Something else we want to keep in mind is there's a way I can write the square root of x in an exponential form. So a square root also represents the 1/2 power. So we talked about that in Algebra 2. All right, similar to if I have a cube root of x, that would be represented by x to the 1/3 power. And if I had a fourth root, the 1/4, a fifth root, the 1/5, and so on. All right, and so if I have something like 5 to the 3/2 power, that 2 in the denominator, just like it was up here, tells me that that is a square root, and then the 3 on top is just the exponent 5 to the 3rd, as you would expect. So this means the square root of 5 to the 3rd power, or the square root of 125, which technically we can break that down into simplifying radicals, like 5 times, not 5, yes, 5. 5 times 25, so I get the square root of 25 is 5, leave 5 in the square root. We won't have to really deal with that much. It'll be more so paying attention to what do we do with negative exponents? What does the little number in front of our radical mean in terms of an exponent? All right, those would be the things that we'll want to try and remember for our functions today. All right, so that's our quick review. So we talked a lot about inverses last week and exponential functions. So if I was going to ask you to find the inverse of the function y equals 2 to the x power. So that's an exponential function. Your input is your exponent. So we talked about that would mean I would switch my inputs and outputs, and then I would solve for y. Is there a way to solve and get the exponent? I would have some students that would say, oh, you divide by 2. I can't divide by 2 because of that exponent of y. I'd have to take the exponent first before I could divide. So there isn't really anything to do except to use another type of function to undo it. All right, so this is where we bring in our logarithmic function. So its general form would be y equals log. All right, then this would be a subscript b, just like when you write H2O, the subscript, so that's what that little b would be like. And then x would be on the same line as log. Log would be short for your logarithm or logarithmic function. All right, and this means the same thing. X equals b to the y power. So our logarithmic function is going to represent the inverse of our exponential functions. Okay, because our exponential, your input was your exponent. Now my output represents the exponent. Okay. All right, so this is called your log form. And this will be my exponential form here. So a lot of your problems are just writing it between these two forms. There's not really a lot of math happening there. We'll solve some equations at the end here, but it's a lot of just converting back and forth between the forms, knowing that they mean the same thing. All right, so that's what we're gonna do first. Let's convert between exponential and logarithmic forms. All right, so here on the left, I'm going to do exponential. On the right side, I'll do logarithmic. I usually write this in a little chart. So if you want to make a little chart, you can. If you've got lined paper, much easier. We're going to have 4 rows here. All right, so my first one, so I've got 3 to the second power equals 9. That is an exponential form. That's a true statement. We know 3 to the second power equals 9. How do we write it in that logarithmic form? So my base is 3. So that's the subscript would be 3. That's always the base for your exponent. All right. The answer to my 3 to the second power problem is 9. So that goes on the line with your log, and then it's going to equal the exponent. Okay, because remember the logarithmic function is the inverse of exponential. So what you're finding is an exponent. We talked about up here that there wasn't really a way to solve and get the exponent, so we must use this other function in order to solve for that exponent. All right, so let's look at another one. I'm going to give you the log version. So log 1/5 is the little subscript. On the same line as log is 25 equals -2. Now it should probably be easier to go from logarithmic to exponential, because exponential is much easier to check with your calculator that it would make sense and that would be correct. So eventually you should get the right answer. But here's the base for my exponential function. Remember, the log is going to tell you the exponent. So here's my exponent. And then that would equal 25. All right, so if you can look at it and know that, yep, that's true. You can also double check with your calculator if you're unsure. That 1/5 to the -2nd power would give you 25, but you should be able to feel fairly confident that you're correct whether you check with your calculator or you're just using your knowledge. Okay? Here's your next two. So 10 to the 5th equals 100,000. Try that one and then try log base 4. 1 over 64 would equal negative 3. So try those two. So if we do our log function, the base is 10. That's my little subscript. Here's what it equals. But a log always tells you what the exponent is. My last example, I gave you the log. The base is 4. Logs tell you the exponent. And then it must equal my 1 over 64. You can double check that with your calculator if you're unsure. If 4 to the negative 3rd equals 1 over 64, hopefully we know that, but you can always use your calculator to check. All right, so that'll be a good part of your homework, is just converting back and forth between the forms. Some of them you'll have to type in an exponential form. Otherwise, all the log stuff is going to be just multiple choice in Math Excel. Okay, the other part to this lesson, we will get to solve equations. So we will solve logarithmic functions or equations. And we'll look at 4 examples of those, and then this lesson will be over. So our first example, log base 4 of x equals negative 2. So every time I solve a logarithmic equation, I'm going to want to convert it to exponential form, because the log form is challenging for me to figure out what to do. If I switch it to the exponential form, I should be able to solve it from there. So the base is 4, log gives me the exponent. Here's what this exponential function would equal. So 4 to the negative 2nd would equal x. If all you do is type 4 to the negative 2nd on your calculator, it will give you that as a decimal. It's going to ask for a fraction form on Math Excel, so make sure you know how to switch it to the fraction or use your exponential rules. And this would be 1 over 4 squared to change it to a positive exponent, which then would be 1 over 16. So that's what I should be entering in through Math Excel as a fraction. Let's try another one. So log base 1/2 of 3x plus 1 equals 2. So in each log equation, your x is going to end up in different places, so it looks a little bit different how we'll end up solving, but same thing as what we did before, we must change it to exponential form first. So my base is 1/2. I am raising it to the 2nd power, and it must equal 3x plus 1. All right, so what I'm trying to solve for is x, so I want to get that by itself. First, let's take 1/2 to the 2nd power. So 1/2 times 1/2 would be 1/4. I'll need to subtract 1. So if I take 1 away from a 4th, I would be left with 3/4, but it would be negative. Right, I got a quarter. I got 3/4 left, but I'm subtracting it a quarter minus 1. Equals 3x. So I want to divide by 3 on both sides. I am dealing with a fraction on the other side, so instead of just writing it as over 3, it might be easier for you to write it as times 1 over 3. It still eliminates the 3 on this side, but then it makes it a little easier to multiply those fractions together just straight across the top and bottom. So 1 times -3 is -3. 3 times 4 would give me 12. If I enter that in Math Excel, it'll probably come back and say you need to make sure you simplify your fractions, right? So divide each by 3. So -1/4 would be my answer. Okay. Let's try another example. So log base x of 3 would equal 2. So if I change this to exponential form, I got a base of x, my exponent is 2, and it must equal 3. So we got a little quadratic equation. You don't need to get it all equal to 0 on one side because we don't have that middle term with an x anyways. We can just take the square root. The square root of 3 would be messy, so if it said you could round to a decimal, you could take the square root of 3. If it wants an exact form, you'll need to use the radical symbol. But technically, there's 2 answers that makes this true, both positive and -3. And it should have that plus or minus button as an option. Okay. All right, our last example here. 4 would be log base 49 of the cube root of 7 equals x. So if I change this to exponential form, I've got 49 to the x power equals the cube root of 7. So this is going to kind of combine what we were doing last week with exponential functions, right? We can't get that x as our exponent, so what we did is we tried to find them to be the same base. So I can rewrite 49 as 7 to the second power. We still have that x as an exponent. And this would be helpful for me to remember how else I can write the cube root of 7 would be 7 to the 1/3 power. So that's why I was trying to go over some of those negative exponent things and your fraction exponents at the beginning. Okay, so now that I have that same base of 7, I can put my exponents equal to each other. And if I divide both by 2, it might be easier, instead of putting it over 2 like that, if I have a fraction on the other side, to write it as times 1/2 and just cut 2 in half. Instead of writing it as dividing by 2, it means the same thing, but then I'm going to multiply this side by 1/2. So then x would be 1/6. All right, so your problems should not take you very long. There's not a lot of steps to them in comparison to some of those word problems and quadratic equations we've been doing. But there's a lot of knowledge pieces on what the form looks like, and then going back to some old algebra rules. All right, so good luck and have fun with your homework. That's a wrap on our lesson today.